Discuss the continuity of each function. Well, basically, we just want to observe that we're dealing with two functions that are both continuous on their entire domains, and we're taking the composition of those functions. So if we look at 12 here, and we have the function, let's see, I almost wish I'd called this function h. I called that one h. Let me call this one maybe capital H. Capital H. Because if I let g of x equal 2x minus 3, that's a linear function, it's a polynomial, it's continuous everywhere. And let f of x be the function sine x, we have not proven, but we have stated and believe that the sine function, by what we know of it, is continuous everywhere. So big H of x then will be the composition f of g of x, and according to the theorem above, then it is, since f and g are both continuous everywhere, likewise is the composition of these continuous functions. Little h of x, cosine x, if we let little g of x equal the inside function, cosine x is defined everywhere, also continuous everywhere. F of x is the absolute value function. Now, what we know about the absolute value function is graph is v-shaped, and the two pieces of the graph intersect at the origin. It's basically two linear functions, f of x equals x and f of x equals negative x, pieced together in such a way that they meet at the origin. So it's continuous certainly everywhere except 0, but it's also continuous at 0. So absolute value function is continuous everywhere. So little h of x equals f of g of x, and as a consequence, it too is continuous everywhere. So we just observe that each of the component functions is continuous everywhere, so the composition of them is also continuous everywhere.